example, the following data, is this recording? Here it is. The following data are results in grams of weighing 50 lab rats. That's heaps of them. Oh my gosh, this is going to take ages. Okay, I'm going to zoom out a bit because we're going to fill in this frequency table from it. Notice how I refer to what my data is about and specify the units for the data. Okay, that's interesting. Why did I bother to write that? Okay, maybe just like say if it was probably in case it was an IA. I think I was thinking if you were doing something like this in an IA, make sure your tables have got units and that they're really detailed, what you put in your headings, that kind of thing. So which one, if you had a value of 100, which category would it go in? 100. The first one, yeah. If you had a value of 140, which category would it be in? Good guess? The third one, yeah. Why the third one?
Because it's greater than or equal to.
Yeah, exactly. It's got the equal to sign on the 140. Whereas here it's less than 140. So we could do it any way you want, but we'll practice doing something like that because you would have to do something like this in an IA. You can maybe also fill in this table. You notice the last one was filled in for you. You could do a tally table. You could do a running tally on the side if you prefer.
Let's try. They were trying to put that into our calculators. What do we put in for like the class people?
It'll be the midpoint.
Okay.
Yeah, that's a good point. It'll be the midpoint. Be really boring for the person watching, so I'm just going to pause it while we do this.
Yeah, it's up. Hell yeah.
Does it give us, how many were we meant to have again?
50.
And do we get 50? Oh, yay. It'll do, we'll accept it. So if you want to call that something, you call it a tally. And Lauren before was asking, so what would go into, that's your frequency column, so that's your L2. What would go into your calculator as your L1? The midpoint, yeah. So if that was really complicated, how would I find the midpoint if I just didn't know automatically it's 110?
You do 100 plus 120.
Yeah, exactly. Yeah, you just average the two endpoints. So 100 plus 120 is 240. 240 divided by 2 is 110. And then just look at it to see, does it make sense? So if you've got something like 500.
We have to find the midpoint?
Yeah. So midpoint's what would go in your X column. Midpoint's now your X, because we can't enter that class interval into a calculator, but we can enter in the midpoint. What do I ask you to do with this? Oh yeah, what's a modal class? It's got the highest frequency. What is the mode? Is there more than one? There is just one. There is just one. And yeah, how do you write your answer? Do you write the midpoint?
No.
No. What do you write instead?
You write the circle.
And you write it exactly the way it's written. Like, don't change it to how it's being presented in the table. Like, don't say between 140 and 160. Actually, right. It's got the highest frequency at 10. In which passes a median line, we'd better use that position equals n plus 1 over 2. What do you use instead?
Why don't we get it?
Oh, that? Certain things they just think that, oh, you must know this so off like the back of your hand. I think Pythagoras and things like that, they don't really need to do that. And maybe SOHCAHTOA. I don't think they're putting SOHCAHTOA for you.
Could you go up just a sure. So if the total will always be n.
Yeah, total frequency. Yeah.
Thank you.
So that's to find our little middle. Yeah. So it means the average of the 25th and the 26th position. So we've got to find out where would be the 25th position, where would be the 26th position, and let's hope that they're both in the same class interval. Yeah. Oh, I hate it when that happens. Okay, that's no good. So total, running total's 4, 6, so we're not up to the 25th position yet. 16. Oh no, you're right. Yeah, so that's what I'm not sure how you would write that answer then.
Would you add all of them together and divide by 4?
If it was just two separate numbers, you would just find the average of the two. But when it's between these, you could say either in here or in there. So I tend to say I tend not to find exam questions on this where it's like this. But if you did, I would say it's either in here, in 180 to 200, or 200 to 220. Some people say 180 to 220. Yeah, so you could say from 180 to 220. Because you don't know whether it's in that one. The 26th position's here. The 20, whatever it is, 26th position, like it was in that one. We don't know what those exact values were. Like it could have been 200, it could have been 189, it could have been 210 for all we know. So we could say, what was it again? So we could say from 180 to 220. That's one way you could write it. Or you could write the two class intervals and say that one or that one. It's always a shame when it ends up being between two class intervals. Find an estimate of the mean. And the reason why we say an estimate of the mean is we don't know what the exact data values were. We just know how many were in each group. Like 4 numbers were in 200 to 220. We don't know exactly what those numbers were. So using the midpoint is a way you can estimate what the mean would have been. So you could do it by hand if you want, or you could try doing it on your calculator. What would you enter into L1? Yeah, the midpoint, yeah. Right, on calc, on GDC, enter midpoints into L1 and frequencies into L2. To L2. And then once you've done that, you go stat calc, 1 bar stats. And you've got to tell them the X list is L1 and the frequency list is L2. L1. So, and then tell them that the frequency list is L2. So make sure you do that. So stat calc 1 bar stats, and then you've got to don't leave your frequency list blank because it's a frequency table this time. It's not just a list of data. So that's important. Tell them. Do you know how to enter in L2?
Yes.
Yeah. You just go second 2, and the number 2 is how you enter in L2. second one is how you enter in L1. So just be aware that next time you find a mean or a median with your calculator, if it's just a single list, you might need to delete that up later on the next set of questions. And what do we get for our lovely mean? Our estimate of the mean. Oh yeah, I was initially trying to tell you to do it by hand by adding the FX column, but it's going to take forever. And
I got
200? Really?
Same.
201.2?
Yes. What is the second thing?
Is your frequency list when you did this? Did you have frequency list entered as L2? Double check that. Yeah, because that's a common error. People will forget to tell them frequency list because it's a frequency table. It's two lists. L1 and L2.
I did my frequency as L2.
Oh, could just be there's a number wrong in the table.
Wait, is it the X line?
Yeah. The first
When you
one.
do it on the calculator, like with the table, it's 200.
Oh.
Is that what we're doing? It's like with the table and stuff, but then when I calculate it, like so I put how much frequency divided by.
Half of you have that and half of you
I
have
got
200.
201.2, but when I did it, like when I did this on the table, I got 200. So, but it's like approximately the same. Like, so it'd be okay.
That's so weird, isn't it? Because like in theory you should
Yeah,
be the
I
same.
got the same.
So you've got your midpoints as L1 and your frequencies as L2.
Wait, do we do
All of
one or
it?
2 bar steps? 2 bar.
One bar. It's one bar.
Oh,
Yeah, that's a good point. Yeah, because it's just a single variable, and the second thing is just a frequency. So the second thing's not a new variable. The second L2 is not a new set of variables. Like it's not like suddenly time or distance. It's just a frequency that related to the original variable. So we're just dealing with one variable, which is the weight. There's not a second one. What did you get, Katie? For your mean. Get your calculator out.
I still got 200. Yeah, I got 200. Even with 1 bar stats. 1 bar stats is the intervals, right? Did you put it, do you remember? I can check for it.
Okay, and you've got your L1 and L2. Oh my goodness! Yeah, that's true. Radians wouldn't affect it. Yeah, that's so interesting. What's going on? Let's just double check our numbers. Stat edit, L1 and L2. Yeah, we've got to have L1 has got to be our X, our midpoints, and L2 is our frequency. What was our midpoints? It started with 110, didn't it? So I'll scroll up so we can see our frequencies. Yep, so 110. Put your midpoints in first. Frequency should always be the second column, just so you don't get confused. That's all.
I got 200. What's wrong with my calculator?
190, 210. Seems to be everyone's getting 200 except for Paige. What's Paige getting?
I got my meeting.
And for some reason, my calculator does not want to enter in the number 110. I'll just double checking mine. 4, 2, 10, 5, 4, 4. Oh, okay. So stat, calc, 1 bar stats, frequency list L1, sorry, list L1, frequency list L2, calculate. I am getting 201.2.
Haha! Why? Because you're wrong. It's 201.2. Wait, did you?
I've got it.
Huh? Okay, so I got 201.2 when I did it by hand.
Good, okay, good. So we're probably right
So
there.
then I had this stat. Calc, 1 bar stat.
Whoa, he's getting really into this.
Calculate.
Yes?
Little X line is 200.
Did you put in...
1.2.
Did you...
Is there like a mode where you can like change it to like share decimal points?
And Grace, did you have this? Grace, did you have L1 and L2?
Yeah.
As in, like, when you did second calc 1 bar stats, you told it that's L1, that's L2?
Yeah. Well, no, because if you're doing 1 bar stats, then you don't need L2.
Oh, yeah, we do, because that's the frequencies of the L1. Yeah. Yeah, so we need, because notice that our table, it's not just a list of data. It's not just a list of data, it's a frequency. Like there's 4 that belong to this category. 2 of them.
Wait. Scroll down.
Yeah, we'll scroll down, yeah. So you enter your midpoints in L1, enter your frequencies in L2, and then you go second calc. It's 1 bar stats because it's just weights we're dealing with. There's no other variable. Frequency is not a variable in that case. Yeah, stat calc. Sorry, yeah, stat calc. Sorry. Stat calc 1 bar stats. X list, tell it it's L1. Tell them our frequencies are in L2.
Wait, X list is L1. It's 201.2.
Yay! We have confirmed 201.2. Exactly, and that's an exact answer. What's that? If there was any units, what would that be?
Wait, but I don't get why you have to show the. Okay, I got it now. How do you put it in L2 or second two?
Yeah, second two is how you make L2.
I got it! Yay! Wait, but Miss Melania, I don't understand why we have to do both.
Why you have to put in the frequency?
Yes.
Yeah, because this is not just a list of numbers. That's not like, so that's just, so Grace. That's just not our list of number. That's not our list of data. Our list of, there's 4 numbers that belong in that category. So in total, there's 4 of these.
Right.
And there should be 2 130s, and there should be 10 150s.
Yeah.
So rather than writing out 110 4 times in a list of data, and then writing out 140 twice, then writing out 150 10 times, you can do frequency tables instead. So you just put your L2 as your frequency, but then you just have to tell the calculator that my data is not just that list of numbers, but it's that list with those frequencies applied. And so just be aware, if your next question that you would do was just one list of data, L2 is still going to be there, so you'd have to delete it out, just to tell them that it's just a regular list of data. So you just have to be very aware of your frequency lists. I think we're moving on. So yeah, what are the units basically? If I asked for a unit for your mean, what would it be?
Weight in grams?
Yeah, in grams, yeah. So it would be grams. You are right. So here I kind of, initially we were going to do that one by hand, and some of you did, which is great. Here's how you use your GDC to find the mean and medians for frequency tables. Stat edit, carefully enter your data into L1 and the frequency into L2. I just tend to, you don't have to do it in that order, but I just tend to do it that way. Check it's correct before the next step. So stat calc, 1 bar stats. Your X list should say L1, if not enter in L1 by pressing second 1. And your frequency list should say L2. And just a reminder, the way you write that is you go second 2. Is how you make L2. That's if it's a frequency table. Okay, so, oh yeah, and by the way, the mean is, this is the symbol, X with a line. And for me, if I want the median, you would have to scroll down. The median is 200. So we got 201.2 and the median was 200, was it? Yeah. So you need to scroll down to see this, to see the median. Whereas the mean appears at the top. That's the symbol for mean that you see in the calculator. You see the X with a line on the top. The median, they call it med, but you need to scroll down. So the mean's easy because that pops up the top of the list, but the median's right down below. Same with your quartiles, your lower quartile, middle quartile, they're all down further.
Are you going to go over that?
Yeah, that's another topic in the stuff I just handed out today. I think I must have decided we needed one more example.
I needed 2 more examples. I don't think we need any of them.
So people were surveyed in a shopping centre as to their shoe size. Put this into a frequency distribution table. Again, I think it's kind of helpful for an IA, because in an IA you kind of need to make a table of some kind. So some people aren't sure how to make a table. What would I put in my first column?
Your shoe size.
5, 6, 7, 8, 9. What would I put in my second column? Frequency. 1. I think I must have just thought that we'll do this one by hand. So I think I just decided let's do this one by hand. FX did, yeah. So how do I work out, Kalvina, how do I work out my FX column? Yeah. Yes, exactly. So what would be my first FX?
Applies.
Yeah, that's an F5. Looks like an S. Looks like a S. And then the next one, everyone can join in if you want. Alright.
77.
Thank you, Sarah.
32.
Yeah. And what two totals do we need?
Your frequency and your FX.
Yeah, good. We only need those two totals. What's my total frequency? Is it 49?
What?
Oh, so these are them.
49.
So what is it? Thank you. 23. And what's our total FX?
And that's what I was
And maybe let's just write total here so people would know what it was.
153.
153.
Oh, that's awkward. I'm definitely wrong.
Yeah.
Sarah's right.
No, what did I just do? Thank you. 158. Okay, let's change that. Thank you. And because that might be useful, and then we just answer the thingamajiggy. How many people were surveyed?
23.
A lot, yeah. What's the range in shoe sizes?
4.
4, yeah. How did you get 4?
3 minus 5.
Okay, good. Top, max, minus, min. Good. What's the modal shoe size? 7, yeah. Remember we can have 2 modes at most, but there's only one this time. What's the median? Ew! Some people would look at it and just think, 7, but you need to find the median position.
Yeah, you're right. It's 7.
It might turn out to be 7 anyway, yeah. 7 equals n plus 1 over 2, which equals 23 plus 1 over 2 equals a 12. Is 12 the median?
Yeah.
No.
No?
It's just the position. It's a 12th number.
Oh,
yeah.
I thought we were.
No, I'm tricking you. So the first 2 numbers are 5s. The next 5 numbers are 6s, so that's a running total of 7. So would you agree the 10th number must occur here? So the 10th number must occur in this group, so shoe size 7. What's the mean shoe size? How do we work it out? What do we divide? Sarah, what do we divide to find the mean?
Divided by the amount of shoe sizes.
Yeah, but what 2 numbers do we do?
What do you mean?
Oh, what 2 numbers do I put in my numerator and denominator, please?
3 divided by.
Total FX over total frequency. Because you always divide by how many you've got, yeah.
158.
Yeah, 158 over 23. Always divide by how many you've got, do you know what I mean?
No, I lied.
6.87.
6.87, yeah, which makes sense. It's good that you were critically analysing your answer, like a shoe size of 23, it's a bit weird. So then you look back at it. So 6.87 for 368. Again, you can't get a shoe size of 6.87, but the mean is just an abstract concept. It has to be a real world study. Yes, basically. Okay. Good. Am I recording? I really hope I am.
Hey, did you find that?
Yeah.
Not
Food, yes. Quickly come back to us. Can we go to the next page? Is that okay?
Yeah.
Thanks. Oh gosh, there's another one.
I told you we don't do this.
Yeah, let's leave those ones.
Oh, you have another one actually.
Yeah. Are you happy with this stuff? Like you're pretty good with it? I don't know why. I did a bit of overkill. Yeah, it's just the same thing. So feel free to do those for practice. Let's move on to, we're just skipping ahead because we just realised the next 2 pages were examples of what you seem to have mastered already. So you can do those 2, the next 2 pages, Katie, you can just do as practice instead. So we're skipping ahead to box and whisker, interquartile range, and outliers.
We're skipping pages?
Yeah, you can do those as practice because they're just what you seem to have mastered already.
But we don't have them
Oh, they're the new things I think I just gave you. Yeah, I just gave you the new ones. Did I have not even given them to you. Oh, some of you don't have it then. Okay, right. Here you go. Lesson 6. Do you have it? Anyone else not you?
I really appreciate you hole punching these.
You really like the whole punching, don't you?
Yes.
Good.
I can almost find it.
It's a really good, this is the only copier in the school, well, that I know of, that hole punches for you. So you can make the copier upstairs hole punch. So if any teachers that you have don't know that, they just go to, when they print, they just go to finish, and then they select hole punch, and they may say 3 left. You have to select 3 left. A lot of people don't know that one hole punches. It's the only one that does, I think. Box and Whisker, interquartile range and outliers. So when you did CIE, IGCSE, you probably learnt about interquartile range. You might not have learnt about box and whiskers though. Interquartile range. Cool. Anyway, let's just do it.
Yeah.
In this section, we examine ways to measure the spread of data. That's why we've spread stuff onto bread. It's the spread of data, like how widely is it spread around the median. So is the data all really close to the median and narrowly spread, or is it really widely spread? So see, the box and whisker plot tells you that. So this median, this tells you that it's kind of gone from, that's the lowest point, that's the highest point, that's how widely spread it is around the median. And these little boxes in between tell you how widely spread is the middle 50% of the data. Owen, pay attention please.
Everyone else was looking at the same.
Only you and Isabella. Your rebellion is being recorded on the video. Okay, so we've got the median. So this little box here is telling you how narrowly spread is the middle 50% of the data. Sounds bizarre. Okay, so if the data is really close together, then this little box will be really narrow, and the little whiskers. Here's the box, and here's our little whiskers. Have you heard of the lower quartile and the upper quartile?
Yeah.
Okay, cool, yeah. So median is a line you draw through the middle of the box. The lower quartile is the boundary of the bottom box. Upper quartile is the boundary of the top, and that's the top maximum value and the minimum. If you forgot lower quartiles, think of it as like the median of the bottom half of the data, and the upper quartile is like the median of the top half of the data, and the median is like the median of the whole set of data. And you've got your lovely little scale down here. So according to this little box and whisker plot, around what value would be the median? Yeah, a little bit higher, yeah, more like 83. Asked to interpret it. You could also be given a set of data and asked to draw one. That could happen. So interpreting them is nice and easy. So, but the only thing is, in the question, they wouldn't have these things written at the top. You would just have to realize the median's the middle one.
But
Yeah.
they give it like that and then a scale.
Yeah, and a scale. Yeah, and they'll probably have a little label here too, like.
The R.
How accurate do you have to be in
That's not clear.
like saying what?
You're like 2 separate things.
Normally, it would have been really obvious. Like they'll have a really clear scale, and normally these things fall exactly on one of those numbers. Yeah, so it's got. Oh yeah, we better do that. So what is the maximum minus the minimum thing called? The range. Yeah. Oh no, I don't want to do this. Denise, there's something is the upper quartile minus the lower quartile, although you said you didn't know what it was. Interquartile range. Interquartile range. So the range is like the length from the lowest, the minimum, to the maximum. What's the range of this box and whisker plot? How did you get 50? Close. It's not 50, it's 60.
Oh.
So it's 40.
It's 40, yeah. Yeah, so notice that the box and whisker plot, its maximum's 100, its minimum 60, so its range is 40. What's the interquartile range of this box and whisker? Yeah, something like that, yeah. 90 minus about whatever that is. Yeah, it's like upper quartile minus the lower quartile. Yeah.
Why do you need to?
Why is it even like a concept in maths kind of thing? Yeah. So what it tells you is, it tells you how narrowly spread the middle 50% of the data is. Because you could probably get, like, say, imagine like we all sat a test in the school, and maybe there was a huge range of marks, but that could be the fact that there was one student who got a really, really high mark, and maybe one student got a really, really low mark. But you'd probably expect the majority would be kind of around the middle somewhere. So it kind of is telling you, is the data really narrowly spread around the median? Which means that if it's a narrow box and whisker plot, like if this box part is really narrow compared with the rest, it indicates that there were heaps and heaps of people had the same result around the median. And there might have just been some outliers, which is why the whiskers are so wide. So yeah, so the range to some extent is a bit misleading because of outliers. Like there could just be a freaky high value and a freaky low value.
Or like you still have to use them.
Yeah, yeah, it's still good to find a range, but an interquartile range tells you more what most, like, gives you a better idea of how widely it's spread, because majority of people are probably closer to the median.
Yeah,
Or maybe it wasn't, maybe things were just genuinely really widely spread, in which case the box would be wide as well. Yeah, so it's kind of like telling you how narrowly spread the middle 50% of the data was around the median. That's what the interquartile range tells you. So yeah, interquartile range is something like 90 minus 73 or something like that, whatever that would be. What are quartiles again, in case you forgot? Quartiles break the whole data into equal parts. So the word quartile, what kind of, the word quartile, what does that make you think of in terms of maths? Quartile. Quarters, yeah, exactly, good. So these are splitting the data up into quarters. So the top 50, if this was a test, the top 50% of students, so the top 25% of students got between 90 and 100. The halfway point was at about 80, so the next quarter down got between 80 and 90. The next 25% of students down got between 73 and 83, whatever. And the bottom 25% of students scored between 60 and 73. So it breaks the data into quarters. But it's not the way, therefore, if it breaks the data into quarters, why are some wider than others? Like what? Yeah, that's a good point. So if there was 200 students, in the school, how many scored between 90 and 100?
10.
If there were 200 students in the school, how many scored between 90 and 100? Close. If there were 200 students in the school,
40.
50. How did you get 50? Yeah, because a quarter of 200 people is 50. Yeah, because remember it breaks it into quarters.
You just said that they were different sizes.
Yeah. So it's just interesting. It's more to do with just the way they performed in the test is why they're different sizes.
So they should be all the same.
Nah, they're meant to be different. So, but there's 50 people in this group, 50 people in that group, 50 people in that group, and 50 people in that group. Same width?
Yeah.
Nah. Because there was the top 50 students,
Yeah.
there was a wide range in their results. Whereas the next 50 performing down, there was a narrower range in their results. Their results were closer together.
So like the top 50% could get between like 95 and 100, but then the bottom 50% could get between like 20 and...
Yeah, a really wide range in their results. Yeah, exactly. Yeah, so that's what it is. So in terms of the number of people in each of them, the number of people in each of them is equal. 50 people, 50 people, 50 people, 50 people, like a quarter basically of the total. But in terms of the way they performed, it was different. Like each group performed some performed more consistently, some performed less consistently. Yeah, that's kind of what it's going on about. All right. Okay, so quartiles break the whole data, 100%, like meaning the whole population of students, into 4 equal parts. Lower quartile, so 25% of the people or the scores lie below the lower quartile. So what percent lie above the lower quartile? Yeah, good, 75%. Like meaning that 1/4 is below the lower quartile, 3/4 is above it. That's why there's 3 parts to it. The median splits it into 50-50. 50% lie below and above the median. So, how many? 50% of the scores lie above the median. Certainly upper quartile. Here's the upper quartile. 75% of the scores lie below the upper quartile.
My table's cut off.
Yeah, I know. So that's what happens with this booklet for some reason. It cuts off the bottom. I don't know why.
Oh.
And I've even tried to resave the document on a different type, and I don't know why it keeps happening.
Man.
So the maximum. What percent of the data lie above the upper quartile? 25%. Yeah. So just trying to get the concept that it's split into quarters. That's a quarter of the population, a quarter, a quarter, a quarter. Nice. This one is a reasonably symmetrical box and whisker plot for once. So meaning that the scores were pretty evenly spread. Mind you, the whiskers are a bit narrower than the boxes. That's one thing. So there was more variability between the middle 50% than there sort of was, I would say, for the extremes. The bottom 25 and the upper 25. Here we go. Trying to connect it to psychology again. Let's assume that you're doing an anxiety study. Oh, let's assume you're doing an anxiety.
About the math, Miss.
She's rebelling again on video. Let's assume that you are doing an anxiety study using the fear of negative evaluation scale. Okay. In this experiment, you are collecting the following 11 scores.
You know what you could do for like parent-teacher conferences? You could just play these.
I could. That's very true.
Like, what?
That'd be so joyful.
What do you mean play these?
Snippets. I could make a montage.
You ask how to go, just like set up a little computer, press play.
Sorry, Owen, I'm not planning to do that at the moment, but I could in theory. Okay, so here's our 11. Imagine these are 11 results from this thing. Trying to again connect it to psychology. Fear of negative evaluation, developed by Watson and friend, assesses the degree to which people worry about how they are perceived and evaluated by others. The authors described FNE as apprehension about others' evaluations, distress over their negative evaluations, and the expectation that others would evaluate oneself negatively. 69, this is a while ago. The fear of negative evaluation scale is a 30-item self-report measure, so it must be they fill in a survey, of social anxiety running from high fear of negative evaluation by others to no apprehension about others' evaluations. The FNE has been shown to correlate with the measures of anxiety, depression, and general stress. Distress, sorry, yeah, thank you. The FNE has not been shown to correlate strongly with other measures of social apprehension. That's interesting. So it correlates more so with anxiety, depression, and general distress. So these are meant to be results from that fear of negative evaluation study. How many items, how many subjects were studied? How many people? How many? 11. Yep. 11. So first of all, let's sort the data. How have I sorted the data? Yeah, good.
Smallest to biggest.
Yeah, that's always a nice thing to do.
Always.
Mm-hmm.
If it's a 30-item self-report, why is there 39?
Yeah, what is the average?
I don't know. Maybe there's a certain amount of points per item. Like there's more than 1 point you get per item or something. Oh yeah, I think they said it seems to appear from high fear of negative evaluation. So I'm assuming these people have high fear, and these people are more like this one, to no apprehension or low apprehension. So assuming these guys have high fear of negative evaluation, and these guys don't so much. Anyway, so I'm just trying vainly to link it to psych. Find the median, the first, and find the median first, the middle value. Can I understand what I've written?
16.
16, yay! There it is. So yeah, when it's in order, that's nice and easy. And it's only 11 numbers, so we can just work out the middle one. Now ignore the median and find the lower quartile. So we ignore the median, and now to find the lower quartile, we just look at the bottom numbers to the left of the median. We don't include the median.
So what would happen if there was like a 0.5?
Yeah, then there could be a 0.5, yeah.
So,
Like if it was instead if there were 6 numbers,
so like, okay,
and there
if
was
we
the middle
ignore
with 12 and
the
13.
8, right? Would we just go
Yeah.
10 to 16 and then 16 to 31?
That's a good point. Yeah, so if we ignore the 8 in general from the whole thing, then the median would now be 16 still. And then yeah, because it would be the middle of 16, so then you would kind of look at all of these
Okay,
numbers,
right.
yeah, and all of those ones, because technically the median's the middle of those two, yeah. Let's give it up. Yeah, that's a good point. So in this case, the median was an exact number in the list, and in that case, we now ignore it, and we just look to the 5 numbers to the left to work out the lower quartile. The lower quartile is the median of those 5 numbers to the left. So what's our little lower quartile?
Wow.
What's the symbol they give that in the calculator? It's a Q?
Q1.
Yeah, they call it Q1.
That sounds stupid, so I stopped.
Q1. They call it Q1.
Would the median be Q2?
Yeah.
No,
In
the
the-
median.
The median is, yeah, the median is Q2, but in the calculator they call it MED. But you're right, it's called technically called the second quartile. And that the upper quartile is the third quartile.
The upper quartile.
Yeah, but it's a second quartile that's got its own special name as well, which is the median. You find the upper quartile by finding the median of the top half of the data. So ignore the median, ignore the 16 in the middle, and just find the median of the top 5 numbers. In this case it's 20, and that's Q3, which is how Teddy should realise the median must therefore be Q2. It's the second quartile. But we just call it the median instead. Sometimes you ask for a 5-number summary. They want the minimum, lower quartile, the median, the upper quartile, and the maximum. So what's our 5-number summary of this data? What's my minimum?
8.
8. Q1.
12.
Wow.
My median.
16.
My Q3.
20.
My max.
39.
The range is like 20 minus 12.
Yes, right.
Yeah, the interquartile range is 20 minus 12. What's my range?
30.
It's like 31.
Yeah. 39 minus 8 is 31. Interquartile range is Q3 minus Q1. 20 minus 12 is 8. Like you said.
No.
What can you do with that info? Like, what's the point of that? So from that, you can draw a something.
Draw a
Box.
Yeah.
or
You could draw a box and whisker plot. Because if you did some research and they were your results, if you did a psych study and they were your results, how boring is it to read that list that I just wrote in pink and green?
I know.
If you display the box and whisker, they can visually look at it and go, hey, there's a huge spread of data, or there's a really low bottom whisker. Do we expect there's going to be a big whisker towards the top or a big whisker towards the bottom by looking at that number? Which one's a freaky value, maybe? Like really away from the median, really away from everything. Like is 8 pretty far?
Being math?
39.
Yeah, the max. So we might expect a big whisker towards the right. That's all we anticipate. But it's not until we draw it that we would actually see that that's the case. Which will show you, draw a box and whisker plot, which will show you that something of the data. Spread, yeah, good. So it shows you the spread of data. Around that, median, good, yeah. It's not around the mean, it's around the median. We'll draw some box and whiskers next lesson.
Yay.
Wicked. What you should be doing for next lesson is do some of the exercises to do with this topic, which I might come and check and report back on for PTC. So do some exercises. How is it? Yeah, math tomorrow.